Okay. So, just a quick recap of what we did yesterday, that is we are considering decimation. Decimation means suppose a sequence is obtained, just for an example, obtained by sampling an analog signal x a t, and we had these samples 0th sample, then tau is this much, this is the sampling period, tau, then 2 tau, 3 tau. So, I take a sample here, this is sample number 1, then sample number 2 dot dot dot, sample number m minus 1, then mth sample, m plus 1th, m plus 2th dot 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 2mth, etc. Right. Now, suppose I say that I want to bring down the sampling rate, I do not want to sample at that high rate, that is sampling period should not be so small tau, it should become wider by an integer factor capital M. So, that means instead of tau, my sampling period will be m times tau period, because period going up means rate going down. Okay, reciprocal of period is rate, speed. So, that means m tau. So, after 0 I have tau, 2 tau, 3 tau, m tau means here, which means after this 0th sample I will pick up the mth sample, I will discard the intermediate samples. Then again m plus 1th, m plus 2th, all these samples I will discard. After mth I will go to 2mth, because m tau, 2m tau, these are the sampling instances. So, that means I will get from the previous sequence I will get x0, then xm, but xm will be sample number 1, x2m, that will be sample number 2, like that. Alternatively, the sequence could have been obtained just by offline, you just generated this data through a computer or whatever, not necessarily obtained by sampling an analog signal. Even then, you take 0th sample, then discard the next m minus 1 sample, then take the next sample, that is mth, call it first sample number 1, then again discard this next m minus 1 samples, then take only the 2mth guy x2m, call it sample number 2 dot 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 dot. Then this sequence will be called the sequence decimated by a factor m, and this is called a decimator. M is an integer, m minimum value is 2. So, xn minimum value 2, because there is no point in decimating by 1, that is you get back same xn, tau remains tau. Okay. So, xn decimated, you get xdn. One thing, since I am bringing down sampling rate, there is a possibility of myself getting into the danger of aliasing, because maybe original sampling rate was above Nyquist rate, but now I am bringing down the sampling rate, making the sampling period wider. So, it is quite possible I may go down eventually below Nyquist rate, which means it might give rise to aliasing. So, that is one thing we should be careful about. All right. Now, that means x0 will pass as it is, will be the 0th sample of the decimated sequence. Then first sample of the decimated sequence will be mth sample of the original sequence, xm. Second sample of the decimated sequence here will be 2mth sample of x2m, minus 1th sample of this decimated sequence will be the minus mth guy, because we are discarding this block, okay, minus mth guy of x, and dot 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 dot, which means from here you can write xdn for any n is x n into m, that is xd1 is xm, xd2 is x2m, xd3 xm dot 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 dot. Then we wanted to find out the discrete time Fourier transform of this xdn, that is decimated sequence, in terms of the original discrete time Fourier transform, and we derived it. The derivation I will not discuss about today again, I will not repeat, but that formula was this, that if you are decimating by a factor m, then the DTFT of the decimated sequence at any frequency omega will be 1 by capital M summation k equal to 0 to m minus 1. So, total m components, capital X the DTFT. DTFT is what? At frequency omega minus 2 pi k by m. So, k equal to 0 means omega by m, k equal to 1 means omega minus 2 pi by m, k equal to 2 means omega minus 4 pi by m dot 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 dot. Okay. How to evaluate this? For that I yesterday gave you one problem, and I will work it out today. That suppose original DTFT is like this, goes up to pi by 2 minus pi by 2, and then 0 up to pi minus pi and repetition, and I want to decimate by factor 2. So, if I have to decimate by factor 2, like here, the summation will have, of course, 1 by 2 outside, summation will have two components, okay, one with k equal to 0, which is e to the power j omega by 2, another k equal to 1, because m minus 1 is with m2 is 1. So, it is where j omega minus 2 pi into 1 2 pi by 2 this. Now, remember one thing, even before I proceed, I told you yesterday pi always corresponds to half sampling frequency. okay, omega s by 2 analog will map to this digital always, irrespective of what is the omega s by 2. And this corresponds to the band limiting frequency omega h. Now, in omega h, since pi by 2 is half of pi, omega h is obviously half of omega s by 2 in this. But to avoid aliasing, it is enough if omega h is equal to omega s by 2. That is, this pi by 2 goes up to pi, which means omega s by 2 is unnecessarily twice of omega h. It could have, the sampling rate could be brought down by 2, so that omega s by 2 is actually omega h. In that case, pi, if I bring down the sampling rate, that is, instead of omega s, I make it omega s by 4, omega s by 2 is a new omega s prime. Okay. So, new omega s prime by 2 will be pi again, okay. But that will coincide with the band limiting frequency, okay, because originally this half sampling frequency is twice omega h, because pi is corresponding to half sampling frequency, pi by 2 corresponding to the band limiting frequency, because after that this is 0 and this is double of this, means in the analog domain half sampling frequency is twice omega h. But this is unnecessarily twice, I can bring it down, instead of omega s I make it omega s prime is omega s by 2. So, half sampling frequency is half of this, that means that is equal to omega h now, because omega h was the half of original half sampling frequency. Now, half sampling frequency has been brought down by 2. So, new half sampling frequency omega s prime by 2, that will be same as omega h, but omega s prime by 2 always maps to pi. So, therefore, omega h will map to pi. So, this would be like this then. No aliasing though, this is what we should have, and we will see that by this formula also we will get the same figure, that is what we will see. Okay. So, what we have given I am rewriting. This is what is given. Okay. We have to evaluate x d e to the power j omega, which by that formula we have already written is x e to the power j omega by 2, another component x e to the power j omega minus 2 pi by 2. All right. So, let us find out this, then find out this, add and divide by 2. This divide by 2 is something I am not much bothered about. So, let us start with this guy. Now, x g e to the power j omega, that is some function of omega. You can make it simplified, function of omega is given. So, this is a function of omega by 2. It was a function of omega, E is constant, J is constant, it is just a representation. Actually, it is a function of omega, it is a function of omega by 2. So, if you call it f omega, it is f omega by 2. F omega is plotted, how will f omega by 2 work? Now, if f omega by 2, to make it crystal clear to you, so that you do not make any mistake and do not get confused, f omega by 2 is not f omega. So, I can call it give it a new name, g omega, and I have to plot g omega, that is f omega by 2, that is g omega versus omega, this is the task. But g omega is f of omega by 2, f of omega is known to me. Okay. So, at any twice omega, what is the value of g? G twice omega is f of omega. Okay. So, whatever happens at any omega, say f omega, suppose this is the omega and this much is the f omega, this value will go to twice omega in this new plot, which means pi by 2, this will go to pi, minus pi by 2 will go to minus pi, because whatever value I have in the original plot at any omega, for g, that is this, the same thing will happen at twice omega, because g 2 omega is f omega. So, at any omega, whatever value we have f omega, for g it will come the same thing, because there is equality, will come at twice that omega. So, pi by t towards 0, so at pi it will be 0, minus pi by t towards 0, so at minus pi it will be 0, and every value. This, if it has omega, this will come at twice. If we call this as omega, any omega, this will become at twice omega, the same value. Likewise, so it will be like this, will get widened, all right. Then pi by 2 has come to pi, this part, pi will go to 2 pi, this 2 pi, 3 pi by 2 will go to 3 pi, okay. Pi goes to 2 pi, 3 pi goes to 3 pi. Then, so this pi by 2 to 3 pi by 2, there are zeros. So, these 0 values are coming here, because at any frequency omega, whatever is the value, that will come at twice that frequency. So, pi by 2 becomes pi, pi goes to 2 pi, 3 pi by 2 goes to 3 pi, all these values are 0, so zeros here. Then from 3 pi by 2, which is 3 pi here, then 2 pi means 4 pi, and then 5 pi by 2 is 5 pi. So, in this zone, again I have some repetition, 3 pi to, then center point is 4 pi, twice that, then here twice that is 5 pi, dot 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 dot. And on this side, minus pi by 2 become minus pi, twice that, and then this minus 3 pi by 2, so that will become minus 3 pi. So, from here to here I had zeros, so minus pi by 2 will go to minus pi will go to minus 2 pi, minus 3 pi by 2 will go to minus 3 pi, and then from here to here minus 2 pi becomes minus 4 pi, minus 5 pi by 2 becomes minus 5 pi, and you have one more such block, and dot 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 dot. Now, you see, this is not periodic over a period 2 pi, because minus pi to pi, then zeros, then this. So, it is not coming here. If it were periodic over a period 2 pi, so whatever you have from minus pi to pi, that would go here, but it is not. That is because this is not the DTFT. X e to the power j omega was DTFT, that is periodic over pi omega over a period 2 pi, from minus pi to pi, whatever you have, that gets repeated. But this is just x e to the power j omega by 2, which I am plotting not versus omega by 2, but versus omega. That is why this is not periodic over a period 2 pi. Fair enough. This is what I have here. How about this function? If I call this g omega, okay, because x e to the power j omega was f omega. What is g omega? F omega by 2. That is x e to the power j omega by 2. That is g omega. Then how about this x e to the power j instead of omega, omega minus 2 pi by 2. This will be g omega minus 2 pi, because when it was omega, g omega as plotting, it was f of omega by 2. F of omega by 2 means capital X to the power, earlier it was j omega, now instead of omega, omega by 2. So, now what is g omega minus 2 pi? Omega minus 2 pi means x to the power j, instead of frequency omega, it is omega minus 2 pi, and then by 2 as it is. All right. So, this is g omega, and what is this? Instead of omega, you see, is a function of omega by 2 instead of omega, is total thing. If you call g omega, then instead of omega, frequency has become omega minus 2 pi. So, it is not g omega minus 2 pi, as simple as that. So, if this was g omega, then g omega minus 2 pi is, right shifted version of this by 2 pi, this omega minus 2 pi. So, if you plot it, that is g, if you have to plot it, this entire thing will get shifted to the right. So, minus pi will come to the right by 2 pi, because shifted by 2 pi. So, this will come here, pi will go to 3 pi. So, you will have here things like this. This minus pi is here, and minus 3 pi it will come to here, because if you add 2 pi to it, it becomes minus pi. So, this 0 block will come here. Then again minus 3 pi here, and minus 5 pi will come to minus 3 pi, because if you add 2 pi to this, you are shifting to the right, you will come to minus 3 pi. So, this block will come here, then 0 from here will come here, likewise, then zeros. Okay. If you add the two, you get the final DTFT minus pi to pi and then pi to 3 pi dot 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 dot. Okay, this is DTFT. All right, and you see this is the figure I said you will get. It will go from 0 to pi, again the same thing will repeat. Because half sampling frequency and band limiting frequency, they are not coinciding, because I brought down the sampling frequency and therefore half sampling frequency by a factor 2. So, earlier half sampling frequency was twice the band limiting frequency, that is why it was pi by 2 so pi. Now, half sampling frequency is same as band limiting frequency, but half sampling frequency always maps to pi, therefore, band limiting frequency also will map to pi. That is why band limiting ends here and then new block again starts like that. Okay, this for decimation, you can work out other examples. There is another very important thing, that is called expansion and interpolation. Before interpolation, before that I will consider something called expansion. Expansion is denoted by, say, by a factor, by an integer m. It is denoted by this. You give XE for expanded, XEN. It means it is a very simple thing. Suppose originally I had x0, 0th sample, x1 first sample, x2 second sample, 2, 1, 0. Now, I create some intermediate points, m minus 1 points, and I put 0 here. So, m minus 1 points. So, this will then, if this is 0th sample, this will now become mth, because already m minus 1 gone, 0 and then 1, 2, 3 up to m minus 1. So, this is m. Again here I create intermediate points and bring zeros. So, again 1, 2, 3 up to m minus 1. So, this will become 2m. This is m plus 1, m plus 2. So, m plus 2 m minus 1, m plus m minus 1. So, next is m plus m, that is 2m dot 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 on this side also. So, earlier if I had a sample here at minus 1, I bring in zeros, m minus 1 0. So, this will become minus mth point. Then this sequence will be called expanded sequence, expanded version of XN. It is like this. If suppose this was obtained by sampling an analog signal of this kind, you are sampling. So, you use so much sampling period, right, this much sampling period. So, your 0th sample, first sample, second sample, third sample, like that. Now, what is happening? I do not have, after I sampled, analog waveform has disappeared. So, I do not have the waveform again, but what I am doing, I am creating new sampling point, as though my sampling period has gone down, sampling frequency or sampling speed has gone up by a factor m. So, if it was tau, previous sampling period, it will be tau by m, because if it is tau by m, then m times that will be tau and ms sample will be here, all right. So, that means tau by m, another tau by m, another tau by m. So, I am creating sampling points at tau by m, where tau was the original sampling period. So, I divide the sampling period by m, very small sampling period means faster clock, sampling period has gone up by m. So, I have new sampling periods, tau by m to tau by m, theta m dot dot dot, and then m into tau by m will be mth. So, this will be mth sample now, okay. And this at these sampling points, since I do not know the analog wave from now, this has disappeared, this has gone already, I am putting just 0 values. So, that is the meaning of expanded sequence. For this expanded sequence, what is say XEZ? If I do XEZ, you can find out DTFT also. What is XEZ? XEZ will be by the Z transform formula XEN, assuming some ROC and all that. But this is what? Dot 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 XE, if you take -1, Z to the power +1, then XE0, then XE okay, I mean, I do not have to expand here. From here only you can see, if you carry out this summation, we will have XE0 term, right? XE0 term will be this guy, all right. Then XE1 that will be 0, XE2 that will be 0, XE3 that will be 0. So, those terms I ignored because they do not contribute anything. Straight I go to XEM, so n equal to m, XEM and Z to the power -m. Then again next term m minus 1 terms I ignore. I go to XE2m, Z to the power -2m. On the left hand side, I ignored this -1, -2 up to this, and then straight go to XE minus m, this guy, the minus point now, Z to the power +m and dot 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 dot. Okay, so this summation is XE0 as it is, then XEM Z to the power -m, XE2m and on this side all right. What is XE0? This same as X0. What is XEM? That was original sample number 1. Okay, original sample number 1, X1, in terms of X, X1. What is XE2M? Original X2. What is XE minus M? Original X minus 1. Okay. Now, Z is a complex number. So, Z to the power m is another complex number, you can call it Z1. So, this is Z1 to the power 1, then X0, then X1 Z1 to the power -1, then X2 Z1 to the power -2, dot 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 dot, which is nothing but summation Xn Z1 to the power -n, you see, which is capital X Z1, which is equivalent to, and what is Z1? Z to the power m. All right. So, what I get is just the Z transform of the expanded sequence capital XZ is same as capital X Z to the power m. So, these relations XEZ is original X Z to the power m, and therefore, DTFT, if Z is e to the power j omega, it will be capital X e to the power j omega m. All right. Remember this I will not come back to again. Now, I come to the topic of interpolation, where we will be using this expansion. Suppose as before, I had an analog signal. Okay. And suppose it was sampled at a lower rate. Okay. So much was my sampling period tau. Okay. So much was my sampling period tau. Okay. And this is done taking care so that Nyquist rate is not violate. I mean, we are above Nyquist rate, even if sampling rate is not high, this is good enough. We are above Nyquist rate, there is no aliasing and all that. Now, my question is, if I employ a higher sampling rate, this of course, I am doing better. Instead of falling below Nyquist rate, I am going up further higher, further above. So, no question of aliasing. But if I had employed suppose m times faster sampling speed, that means sampling rate, sampling period would have been tau by m. Speed goes up by m times means period goes down by m. So, instead of tau, I would have tau by m. So, this is tau by m, and then here like this, and this would have been 1 tau by m, 2 tau by m, 3 tau by m, m minus 1, and this is mth, because m into tau by m is tau. Since I know this point is tau, this will be the mth sample, because tau by m, 2 tau by m, 3 tau by m. So, how many tau by m will make it tau? That is m. So, this will be the mth sample, and so how many intermediate? M minus 1. Now, suppose I had originally sampled this at that high rate, then along with this and this, I also would have got these red colored samples, these m minus 1 samples. Along with this and this, I would have got them. Then again here, okay, I would have got these samples, another m minus 1, again here, dot 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 dot, right. But since I did not do that, I sampled only at the lower sampling rate, I got only the blue colored samples, that is this guy, then at tau sampling period time tau a sample which I call the first sample, then at 2 tau which I call the second sample, this all that. But if I had sampled at the higher rate, I would have had so many intermediate samples m minus 1. So, this would have been mth, another m minus 1. So, this would have been 2 mth like that. My question is, if I am giving this lower, this original sample trend, this sequence, there is this guy, this blue colored samples. Okay, sampling period is a tau, which I call x n. Can I get back this? Can I get back this high speed one? That is this as it is, this as it is, but you have got these red ones. Then again, this one, dot 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 dot. All right, this is, so it would have been, this would have been mth, then this is 0th, this would have been 2 mth, and this intermediate samples would have been here. So, from these, can I get back these intermediate samples shown by red color here? In this sequence, they are not present. So, you can ask me, this is a very peculiar question, out of nowhere. Is it a magic? It is a magic that out of nowhere, these samples, which I cannot take anymore because analog function has gone. I have sampled it, it is gone. So, where from will I get this red ink, red colored intermediate samples? I am only giving this black colored samples, these, or here only the blue valued sample, blue colored samples. Okay. The intermediate samples I could have got, if the analog function was still available, I could have resampled it, but that is gone. So, from this, how to recover those intermediate samples which I would have got if I had sampled it originally at higher rate, at a sampling period tau by m. But yes, still by processing this low sampling rate sequence x n, there is a way by which I can reconstruct these intermediate samples exactly without any error, without any approximation, and this business is called interpolation. Okay, that is in the next class. Thank you.